Find the exact value of each expression. In part A, we have tangent of cosine inverse 2/3. Okay, if 2/3 were a standard angle value, then we could have figured out cosine inverse of 2/3. That would be an angle. Then tangent of that angle would be the answer. But 2/3 is not a standard angle value. So let's say a cosine inverse of 2/3 as some angle. I mean, this will be an angle, and let's say that theta. So let theta be cosine inverse of 2/3. Okay, that means if we move cosine, then we get that is same as cosine theta equals 2/3. And by the way, for cosine inverse, the range, okay, that's theta, is in between 0 and pi. Okay, 0 and pi. And we have cosine theta is 2/3, which is a positive value. That means cosine, I mean 0 to pi means, if we look at the quadrants, 0, pi over 2, pi. So 0 through pi means either in the first quadrant or in the second quadrant. But cosine is 2/3 positive. That means theta is in the first quadrant. So, and we know that cosine is adjacent over hypotenuse. Okay, just R or C. So 2/3. Just draw a right triangle with angle theta, and this adjacent is 2, hypotenuse is 3, cosine is 2/3. Okay, let me erase this. Now we need to find this opposite. Okay, and we know that a squared plus b squared equals c squared or r squared. This is b unknown. So 2 squared, 4, plus b squared is equal to 3 squared, which is 9. Now let's find b from here. Subtract 4 from both sides. B squared equals 5. Take a square root. So square root of 5 positive because this length is positive. Okay. Now the whole question here was to find tangent of this cosine inverse 2/3, and we assume that is theta. So tangent theta. And tangent theta, look at this right triangle. That's opposite over adjacent, b over 2, and b is just found to be root 5 over 2, and that is tangent of cosine inverse 2/3. So the final answer is root 5 over 2. Okay, let's try part B. Here similar. So sine of tangent inverse of negative 12 over 5. So we say this be theta. Let theta be tangent inverse of negative 12 over 5. That is same as, move tangent over, I mean that's same as by definition, tangent theta equals negative 12 over 5. And for tangent inverse, the range is in between negative pi over 2 to pi over 2. Okay, that is here. This is negative pi over 2 and this is pi over 2. Okay, we always go counterclockwise, so either in this fourth quadrant or in the first quadrant. And we have tangent is negative. That means obviously in this fourth quadrant. So we have to draw a right triangle. It doesn't have to be exact. Just draw. So there, this will be the angle theta, and we know that tangent is opposite, okay, over adjacent. So b over a. So in this case, b over a. Now here's a negative sign. So this can be regarded for the top or the bottom. If we look at here, this a is on the positive x-axis. So the bottom, this is 5, not negative 5. This is 5, and b is now negative 12. Okay, negative 12 over 5, same as negative 12 over 5. Now we need to find a, b, c, or this is r or c, doesn't matter. And we know that a square plus b square equals c square. So a square is 5 square 25 plus negative 12 square, negative times negative positive, 12 square, 12 times 12 144 equals c square. C is to be determined. Add and take a square root. This is 169 c square, take a square root, you get c equals 13, and this distance is always positive, so c is 13. So now we have all three sides and this angle is theta. So now we are supposed to find sine of this thing, tangent inverse negative 12 over 5, and we said that theta. So sine theta, and sine theta from this right triangle, opposite over opposite over hypotenuse. So negative 12 over this c is just found to be 13. So negative 12 over 13. That's final.